Okay, so question number 6 is to draw the Lewis structure of ozone, which is O3. So let's find the total number of valence electrons. So oxygen has 6 valence electrons, and there are 3 oxygen atoms. So we have a total of 18. So now I'm just going to draw all my oxygens in a row with just single bonds. And let's see what happens if I fill in all of the lone pairs. Okay, so if I count out how many electrons I've drawn so far, each bond contains 2 bonding electrons. Then I have a total of 16, 17, 18, 19, 20. So I have more electrons than I need. So let's make one of these lone pairs into a double bond. And count out now how many I have. Okay, so now I have 18. And I'm going to calculate the formal charge for each of these oxygen atoms. So first let's label them 1, 2, and 3. So the formal charge equation is the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. Okay, so first let's calculate the formal charge of oxygen 1, which is the leftmost oxygen. Its number of valence electrons is 6. It has 4 non-bonding electrons, so these are the lone pairs. And for the number of bonding electrons, there's a double bond. So we have 4 bonding electrons divided by 2. So 6 minus 4 minus 2 is 0. So our first oxygen is neutral. So now let's calculate the formal charge of our second oxygen atom. There are still 6 valence electrons. And there is only 1 lone pair, so there are 2 non-bonding electrons. And there are 3 bonds to the middle oxygen, so we have 6 bonding electrons divided by 2. And this gives us 6 minus 2 minus 3, which is positive 1. So we know that our middle oxygen has a +1 charge. Let's just draw that in. And now let's do the same thing for our last oxygen. 6 valence electrons. There are 6 non-bonding electrons, and there's a single bond to oxygen. So 2 divided by 2. So 6 minus 6 minus 1 is -1. So we know that our last oxygen has a -1 charge. So this is our overall Lewis structure. And you'll notice that the positive charge and the negative charge will cancel each other out, and we're left with an overall neutral molecule. So if we look at what the junior tutor said, they have the same thing. They didn't draw in the formal charge, so I'll just add that in the comments. So this solution is correct. So I just added their charges.